you go. All right, so the question says, can we go over how to figure out the degree when just given the graph? Yeah, sure. So, and this trick only works for polynomials, yes? If you have a graph that looks like this, what degree of a function is this? Well, you have to count how many curves you have, yes? So that's 1 here, 2, and 3. Yeah, so we have 3, let's call them turns. 3 turns. Since the 3 turns, that means that the degree of this function is x to the 4th. So each time you want to tell what the degree of a polynomial is, the number of turns is going to be 1 less than the degree. And if you want to notice a pattern, let me show you the stuff we already know, like a cubic function. Looks like this. So it has 1, 2 turns, even though it's x cubed. The parabola, only the 1 turn, even though it's x squared. See that? So even though it's x squared, this has only 1 turn, which means it's going to be quadratic, and number of turns is 1 less than the power. And if it's linear, what happens if it's linear? No turns. 0 turns. This is to the first power. Make sense? Gonna be recorded, put on Blackboard. Yes, I'm already rolling. Yeah. Any other questions? Did that help you out? Did that clarify how to do it? Yeah. Awesome. Okay. All right. Next question. Let me just go over the long division on polynomials. Okay, yeah, let's do that. Let me get a question here for you. Let's see. Okay. So, and you wanted long division, so let's do it. Oops, long division. All right, so the question says, I want you to divide, where is it? I want you to divide 7w cubed, 7w cubed plus, where is it? I keep losing the line for some reason. All right, so 2w squared and minus 3w and minus 14. So that's my function, and it's being divided by w minus 1. Instead of x, the question gave you w, but it's essentially the same thing. Right? So what we do is you draw the shape you need for the long division, right? This goes in here, that goes in there, since you're dividing by it. So w minus 1 goes there, and 7w cubed plus 2w squared minus 3w minus 14. And then we get started. Okay, So these are in order, and there's nothing being skipped, so there's nothing you need to do for the function. You just start solving. So first step is you try to match this as much as possible, and you are worried about the w and the power, not the number. Okay? So over here we have 7w cubed. Can I multiply w by anything that turns it into 7w cubed exactly? Yes. To get the 7, you just multiply by 7. And to get the w cubed, you need to multiply this by w squared. So if you do that, you multiply 7w squared by w, this ends up being 7w cubed. So that's my first. Now I'm going to multiply, but I'm going to multiply to both. So 7w squared times w gives me my 7w cubed. Right? And then 7w squared times negative 1 gives you negative 7w squared. Draft line. These two are exactly the same, so the answer is 0. Now, this is a subtraction of a negative. Yes, so this turns positive and that turns positive. So this is going to be an addition at this point, right? So 2w squared plus 7w squared is going to give you 9 plus 9w squared. Next step is you bring this all the way down, writing a 3w over here. We look at the first term again. 9w squared times w minus 1. Actually, times w. I need to match this. So what do I multiply the w by to get 9w squared? So we have 9w multiplied by w gives you the squared. So that's what I'm going to use. Plus 9w. So 9w times w gives you 9w squared, is what I wanted. And then 9w times the negative 1 is going to give me negative 9w. Subtract. So these two subtracted gives you 0. And over here, subtraction of a negative from a negative, these two are going to turn positive. Right? So this is going to turn positive, that's going to turn positive. But that remains a negative. So a positive 9 and a negative 3 gives you a positive 6. This is 6w. Now, I have one last term, so I'm going to bring that all the way down. Minus 14. And one last run. So now we focus on the 6w and a w. How do I turn w into 6w? You simply multiply by 6. Right? So 6 times w, you get 6w. 6 times the negative 1, you get negative. Subtract. These two are obviously going to give you 0. Positive. 14 and 6. The 14 is negative, 6 is positive. The difference would be negative 8. That's your remainder. So if I ask you to give me the final answer of this function, what are you going to say? This right here, this is the solution. So it's 7w squared plus 9w plus 6 minus 8 over w minus 1, because we technically didn't divide that by anything yet. Make sense? That's your answer. Welcome. Any other questions, you guys? Well, here, let me ask you one about this one right here. I'm going to give you a 7. That sounds bad. I'm gonna give you the question already set up, and I need you to tell me what the value of C is. But just a sec. I have one of those questions. Which one? Do you know? Because I kind of make those questions up on the spot. Do you know which one? First quiz. No, I meant the question itself. Do you know what it is? I guess I could go look at it. Okay. Yeah, you're gonna have to tell me what the question is because I have the quiz mixing up the questions every time a student takes it. So what could have been question number 1 for you could have been number 3 for someone else. So you should tell me which one. Do you know what it's about? Did they ask you for the functions or? Okay. Where the quiz located? The quizzes are on under course content. You'll see them posted there, but I only give you the day to do it, so now you won't be able to find them. Yes, we are. This is a review. We're reviewing. She's talking about a previous quiz. I think I gave you guys this one like 2 weeks ago. It was on Blackboard. Let's see. Anyway, so the question I wanted to give you just now, what was it? Okay, so here's the question already set up, yes? We have 1, 9, 9, 4, and then 5. Here we have a 9, 18, 22, 9, 18, 22, and 27. Okay, so this is synthetic division. The division is already set up and filled out for you. I need you to give me the value of C, as in x minus C, which is the linear we divided by. Can you tell me what C is while I read the questions you guys just asked? I'm going to remake it. The quizzes? No, sorry, you can't. But just make sure not to miss any more. When did you send the announcement? In the morning, like when I usually do for tough class time. Even my announcements are timed. They usually get erased so that you don't mix up the new stuff with the old stuff. If you look on Blackboard, the announcement for the second quiz already is still there on October 22nd. Okay, you got it? Okay, just hold on to that thought 1 sec while you guys think about this one. What is the value of C? I want you to give me what C is. Any ideas? No. Okay. So when you're doing synthetic division, if you remember, we spoke of a rule that synthetic division only works if the question looks somewhat like this. We have a function being divided by a pair to the first degree, and it can only be the first degree, yes? So this is essentially x minus 1 instead of w, right? So it would be x minus 1. Now, the setup for a synthetic division to work, what the function is being divided by needs to be in the form of x minus c. And we only write down the numbers when you're using synthetic division. So what is c? -1. Close, but no. We talked about flipping the sign, if you remember. So c is 1, the number right here. Yes, the number you have in that little box right here. It's okay. Now, what was your question? Anna? Still there? Okay, f of x, g of x equals x over 2. That's the question? Because I don't remember giving you that in the quiz. I did multiplication of function. So you're talking about multiplying them? Is that what you mean? Yeah? Okay. So operations. Okay. So when I ask you to multiply two functions, do you remember what f of x and g of x were? Don't worry about it. Okay. So I'll just make stuff up. So it won't be exactly like the question in the quiz, but we'll go with it. Okay, so let's say f of x is, I don't know, x squared minus 1, right? And g of x is 3x plus 4, for whatever reason, right? And I want you to multiply these two together. So that would look like this. Do you want me to use a number, like multiplication where I'm just using the value of x, or do you want me to insert a number? F of 6, for example. Yeah, value of x? Okay. So f of x times g of x. Okay? So I'm going to multiply these two. So this right here literally means that I want you to grab the first one, which is f of x, write down multiplication, write the second one down, and then simplify as much as you can. Make sense? So you're going to give me f of x times g of x, and what it equals. Yeah? So let's see. I'm going to go up a little. So multiplication between these two, you have two terms. I'm going to distribute the multiplication. Now I can either multiply this one in here or that one in there. It's up to you. I'm just going to go with the one on the left. So we have 1, 2 for the x squared value, and then 1, 2 for the -1 value. So x squared times 3x is x cubed, and the 3 goes there. Now x squared times the 4 gives you positive 4x squared. That's done. Now let's do the -1. -1 times 3x is negative 3x, and -1 times a positive 4 makes it a -4. And look at that, they're all different powers, so there's nothing you need to add or combine. It's already ready. That's your answer. Now, as for the form we usually use, the multiplication means, sorry, it looks like this, right? So it's f times g of x. Make sense? So if you see this, I mean that. That's what that means. If you see this, that's not the same thing. These are not the same. Okay? Maybe I shouldn't use x. But these are not the same thing. This one right here means that g is inside of f. The first one we write, like the one on the far left, is usually the one on the outside. So it's f of g of x. Make sense? So instead of x in f of x, right here, instead of having x, I'm having you place g of x, the entire function, in here. Does that make sense? That's what fog is. This is a composition, that's a multiplication. Students confuse these two a lot. Let's see. Square root of x minus 11 greater than or equal to 0. Find the domain and range. Yeah, okay. Let's see. So square root of x minus 11, right? And it is greater than or equal to 0. Okay. Find the domain and range. Right, well, to be able to do this, you need to be able to picture the graph, yes? Now, when it comes to radical functions, which is what this is, and it's an inequality too, you have to be aware that you can't have a negative underneath the root, right? So that's what we need to be careful of. The domain is going to be all the numbers except what turns the inside of the root negative. Does that make sense? So, since I told you that this whole root, x minus 11, is greater than or equal to 0, that means I want you to only include the values that make it either 0 or higher. Therefore, it's always going to be what? Positive, right? So the domain, as far as this inequality is concerned, is all the numbers. Now, let me graph it. Let's see. Right. Now. Okay. You have x, y. Now. Let's see. I'm going to start off with some negative values here, and the values that turn it to 0, since I'm technically graphing this, not that. Yeah. So I'm gonna try to come up with. So we have what? Negative 3, 2, negative 1, 0, 1, 2. That should be enough. Okay, so you have negative 3 plugged in here, so it turns this negative. Obviously, you can't use that. Negative 2 plugged in here turns it negative. Obviously, you can't do that. You see the pattern. So we're avoiding all the negatives. That's why it's greater than or equal to 0. Okay, so all the negative values are not inside. They're not being counted. Okay. Now, 0 minus 11, what happens? It's still negative. 1 minus 11 is still negative. So can you guess what the first value we can use that turns this to 0? At least. Any ideas? 11, exactly. So this right here, 11 minus 11 gives you exactly the 0. So you need to start at 11 and go from there. So your domain is 11 to infinity, or you write it like this, comma infinity, including the 11, so it's a bracket. Yes? That's your domain. So knowing that, you can easily graph it. You start at the value of 11. I'm just going to say it's right here, and you go all the way to infinity. But I still need to figure out my range. Yes? So even though I scratched it out, I'm going to write them right here. 11, 12, 13, 14, 15, just to have y values. So 11 minus 11 is 0. 12 minus 11 gives you 1 underneath the root, which is still 1. 13 minus 11 gives you root of 2. 14 minus 11 gives you root of 3. 15 minus 11 gives you root of 4, which is 2. Alright, those are my values. I'm saying this is 11, even though I didn't leave a lot of room there. But it starts here, so let's call that the point 11. And it's at 0. So for 12, it's going to be at 1. For 13, it's going to be at root of 2, which is slightly above 1. For 14, it's going to be at root of 3. And 15 is going to be at 2. And then it's just going to keep increasing at the slower increment as you go. So the function looks like this. Yes? So it's going to keep increasing. It's just really slow. Yeah? So as far as y is concerned, this function is going to positive infinity. Now, is it going to decrease below 11 or 0 for y? Do we have any values in this direction? No, you do not. Therefore, your range is 0 to positive infinity, including the 0. This is the range. Okay? So whenever I ask you a range and domain question, if you can't picture it in your head right away, graph it. It should always help. By the way, where did you get this question? I like it. YouTube. Okay. Cool. Any other questions? Do I leave this here for a little bit? Okay, polynomial functions. What about it? Polynomial functions are confusing? Those are like the simplest form of functions. You're gonna have to like maybe specify your question a little more. So what do you mean confusing? Are you talking about section 3.2? Is that? Yeah, okay. So so like the end behavior of the function, is that giving you trouble? Okay. So when it comes to polynomial functions, the most important coefficient would be the one of the leading element. Now, to know which one is the leading element, you need to go for the highest power. Right? So if I give you 7x squared minus 3x plus 1, obviously the highest power is 2. And notice how it keeps dropping. So 2 to 1 and then to 0. Like over here you have x to the 0 power. That's why it's not there. So the function, also a polynomial, would be 3x to the 5th power minus 2x to the 4th power plus 3x to the 3rd power minus 7x squared minus 3x plus 1. This is also a polynomial, but it is to the 5th power. Now, in that one, the leading term would have been this one, and the coefficient of that term would have been the 7. In this one, the leading term is the 1 to the 5th power, and the coefficient is 3. So far, so good? Now, the trick here is that you need to look at both these things. You need to look at the number and you need to look at the power. If the power is even or if the power is odd. So you have two possibilities. If the power, power is even or it's odd. Yes? So if it's even, two things are going to happen. And if it's odd, two things are going to happen. So if it's even, that means it's x squared, x to the fourth, x to the sixth. That's the highest power of the equation, or sorry, of the function. So in that case, one of two things is going to happen. The first thing I said, we look at the power, and which gave us these two categories. Next, to figure out what these two are, you're going to look at the coefficient. Now, if the number, we call it A, coefficient, if A is positive, or if A is negative. Same thing here. If it's positive, if it's negative. Make sense? So you basically read the function. You look at the power and you look at the sign of the coefficient. Now, if it's even and it's positive, that means the ends of the function are both going to be pointing up, like this. Right? Again, picture a parabola. That's an even function. If it's positive, it looks like that. But if it's negative, it looks like that. So that's the rule. For even, the ends always match. They always go in the same direction. Now, if it's positive, they're going to be pointing up, and if it's negative, they're going to be pointing down. That's the end behavior. So even is pretty easy. They head in the same direction, positive up, negative down. So far so good? Yeah? Okay. Now, for the odd, we're going to head in opposite directions. But to know which is positive and which is negative, you need to basically read the graph, because the x and y axis should tell you which quarter is the positive one and the negative one. So for the odd ones, if it's positive, then the one on the right is going to go up, and the one on the left is going to go down. If it's negative, it's the opposite. Left is up, right is down. But again, picture axes. Like if this was on an x and y axis, this, right? This quarter right here, where x is positive and y is positive. See that? And it's going positively. Both negative is going to be negative. So if the arrow matches what the x and y values are, then that's positive. Make sense? So for the x positive direction and y positive direction, the function is going up. And for the x negative direction and y negative direction, so this quarter, the arrow is going down. So if they match with the values of x and y, then this is the positive. Another thing that could help, think of slope. If you remember, we spoke of positive slope, negative slope. So if you look at this part right here, the fact that the f of x value is increasing as x is increasing, this is a positive slope. This is an increase. But the negative is the exact opposite. So if I draw imaginary axes here, so notice that it's increasing when x is negative, but y is still positive. Make sense? So x is negative, but the function is still increasing. So it's the opposite of what the x is. Over here, x is increasing, but y is decreasing. So that's the only way you can really tell. Just imagine axes. If the right one is going up, left is going down, it's a positive coefficient. And if it's the left one is going up, right one is going down, it's a negative coefficient. But if I didn't give you these and give you that instead, then you have to remember it backwards too. If it's a positive coefficient, then right one up, left one down. If it's a negative coefficient, it's left one up, right one down. Okay? Finding the zeros. Sure. So to find the zeros, I'm basically asking you to solve. Yeah. So I don't know. Oops. I want to think of a problem where the zeros are gonna be kind of neat. Wait, are we talking a normal polynomial like x squared minus 3x plus 1. Okay, make that 2. Otherwise, it won't factor well. So, are we talking like a normal polynomial and you want to factor it? Or do you mean something like this? Because both can be given to you to find the zeros. The difference between these two is that this one is already factored. This one you still have to factor. Otherwise, they're the same. Make sense? This one's to the second power. This one's to what power? You guys tell me? What's the power of the second one? These are pairs of parentheses multiplied. It's the fourth. Yes, we have a 1 here, 1 here, and 2 here. We add them up, and the answer is 4. How is it to the fourth power? Because this is to the first, that's to the first, that's 1, 2. And over here you have the second, 2 plus 2 is 4. So for example, this one, the first one, if I factor this, you get what? 2 pairs of parentheses. Notice, same thing, multiplied. We have an x and an x. We have a 2, so it can only be 2 and 1. Positive, so they have the same sign, and the addition was negative, so they're both negative, 2 and 1. So notice which part? The factoring? Yeah? Where did I lose you? Yeah, okay. So I'm about to get to that. So notice how this one is a function to the second power, right? The polynomial to the second power. But when you factored it, you got 2 pairs of parentheses, both to the first power. Add them. 1, 2, it gives you 2. Notice that? 1, 2, 2. Over here, the reason I said 4 is because we have 1 plus 2, that's 3, plus another 1 is 4. Yes? So you add the power of the parentheses. So the same thing happens if it was like this. Once I finish factoring it, you see that? It has the first power, first power. Add those two up and it gives you the power of the function you started with. Make sense? So again, for this one, I have 1 plus 2 is 3, plus another 1 is 4. Okay? That's how you know the power if I give it to you factored already. Just add the powers of the parentheses. So far so good? Should I take that as a yes? I don't know. Now, you asked about the zeros, though. How to find the zeros. Okay, so when I'm asking you to find the zeros, I'm basically asking you to find the values that turn this to 0. Yes, so the values that if you plug it in here, instead of x, the answer will be 0. So therefore, you are solving for 0. You set it equal to 0 and you solve. That's why we call them zeros. Make sense? They're also like the primary roots, let's say. The roots. These are the points that cause the function to touch the x-axis. So that's why I was able to factor this, is because we set it equal to 0. Looking here, if I give you a polynomial in this form, you need to factor it first. Right? If it looks like this already, then you already have your zeros. Finding them is really easy. So for this one, usually we say, okay, it still equals 0, right? And then we split them up, and it's either this equals 0 or that equals 0, and you solve for x, correct? Now, when you see a parenthesis in this form, x minus a number or x plus a number, then figuring out the x value is really easy, because you only need to flip the sign in here. you can actually go through the process of writing out x minus 2 equals 0, that, and then grab the negative 2, move it to the opposite side, and it turns positive, and then you get x equals 2, right? Or you could just say, okay, x minus 2, move it, it becomes positive, so it's positive 2. X minus 1, move it, it becomes positive, so it's positive 1. Makes sense? So if it's x minus a number, it's going to be a positive result. If it's x plus a number, it's going to be a negative result. So if I give it to you in this form, I already kind of half answered the question for you. All you need to do is give me the numbers you see in here. Those are the answers. How about this one? Let's practice. Let's do this one. So x equals, for that one. Now we're going to do all of them. Yes? Okay. So over here you have 1, right? Because it was negative inside, that means outside is going to be positive. So this one next is what? Positive 7. And finally, since it's positive inside, once you take it outside, it becomes negative. Therefore, this is negative 2. Now, this one has a multiplicity of 1, but this one has a multiplicity of, there you go, of 2. Now, why do I say that? It's because the pair of parentheses had the second power, which means you had this pair twice. So you have this 0 twice. That's all. Okay? All right. Next question. Oh, thank you for telling me before I move the paper. All right, who has a question? I'm having fun, to be honest. It's like a game. I like solving questions. Okay. Okay. So next question. Did you write this down before I throw away the paper? Did you get this part? Okay, good. Y-intercept. What about it? How to find it? Y-intercept, no intercept. Right? You just want to know when those happen? Okay. So if I give you a function or an equation, because the intercepts occur in all of them, but it's usually a function. So if I give you a function, oh, you have one already. Okay, cool. We have f of x equals negative x minus 2 minus 1. Quick, what's this form? But give a different problem. You want a different problem? Okay. Well, I can easily change it by adding a squared over here. It turns into a vertex problem, but I don't think you guys want that. Exponent. Wow, you asked for it, literally. Okay, so this is a quadratic in what form? This is the vertex form, right? Can you guys tell me what the vertex point is? This one? 2. 2 goes where? Is it the x or y? X, okay. So 2 is the x. And the y is what? 4. K, h, and k. What is y? -1. Alright, cool. Now, back to the problem. So you want to know about the intercept. So rule says, if you're trying to find the x-intercept, yes? If you're trying to find the x-intercept, see, that's why I gave a different. Why? Do you? Because I still didn't start. That's the vertex point. Besides, I added squared. It's a different problem now. This is from section 3.1. The exact problem. I see. But you didn't get, okay. So let's do another one. You want it to be in this form? Should I give you a completely different question? Oh, okay, you want it in this form. So let's say 3 plus 2 squared plus 7. Okay? So working with this, again, quick. What's the vertex point? Two for x? Well, you're right about that. It is 2. It's just negative. And then the -7. It's -2, -7. Now, let's see here. You have the x-intercept. We need to find that first. Now, to find the x-intercept, the rule says to turn y into 0. So whenever you have a function, right? So if it's in function form, f of x is going to be 0. Because f of x equals y, right? So y is equals f of x is 0. So putting this rule into effect, this is going to turn into what? 3 x plus 2 squared minus 7. And it equals 0. Right? Okay. So let's solve. I'm grabbing the -7, moving it to the side. It's going to turn positive. So we have 3 times x plus 2 squared. It equals +7. Okay. Next, I'm dividing by 3 on both sides. Get rid of that. Last step, I need to get rid of the squared, so I'm taking the square root of both sides. And remember, you have to include the fraction, the entire thing in the root. Okay, so the root and the squared cancel and you end up with x plus 2, which equals positive and negative root of 7/3. Right? It could be positive or negative. And then last step, grab the 2, move it here and turns negative. So x equals -2 plus or minus root of 7/3. That's your answer. So these are the x values. Now again, when I'm asking for the x-intercept, I need you to give it to me in point form. So it looks like this. Either -2 plus root of 7/3 and then 0, or -2 minus root of 7/3 and then the 0 for y. Okay, so to find the x-intercept, first step is setting the function equal to 0 and then solving. You basically find the zeros. Kind of like what I just showed you. The same thing as finding the zeros. The idea of the x-intercept. Only this time you don't stop at x equals, you put them in point form. That's it. Now, for y, it's going to be the opposite. X is going to be 0. And for y, always remember that you're only going to have one intercept, you cannot have more. You can't have none. So it is possible that it won't intersect the y-axis ever, but you can't have more than one. Okay. So y-intercept. So for the y-intercept, the x needs to be 0, which means you need to find f of 0. You're going to plug 0 into the function. So instead of f of x is going to be f of 0, which equals. Now the function said 3 times 0 plus 2 squared minus 7. So 0 plus 2 is 2. 2 squared is 4. 4 times 3 is 12, and 12 minus 7 is 5. Right? But we don't stop there. We have to give it to me in a point form, so it's 0, 5. That's your y-intercept. So those are the ones you calculate. When does a function have no intercept? Is when you do all of this, and then you get to a point where it's unsolvable. For example, if this is, instead of -7, if it was +7, when you move it, it's going to turn into a negative. And even if you divide it by the 3, you're going to end up with something squared equaling a negative value, which means you're going to have a negative number underneath the root, and that's unsolvable. It doesn't happen. Therefore, no solution. Make sense? So you only get to see no intercept is if I just did same one. 3x plus 2 squared plus 7. The function looked like this instead. When you move the 7 over, equals 0. So 3x plus 2 squared equals -7. Now you have a problem, because even after you do the division like this, the number over here is still negative, right? So take the root, we have a problem. We have a negative underneath the square root. Make sense? So there's no solution. And since there's no solution, you obviously can't get the points. Make sense? So no intercept is when you can't solve it, whether for x or y. Yeah? Okay. Next question. Let me do this so the entire thing is in view. Maybe a little more. Yeah, you can see the bottom now. Let's give it a cut. You have the function down. Can you copy that part? Because it's not possible for me to get it within screen. Oh, okay. All right. So, any other questions, you guys? We still have 30 minutes, so yours. You ask. I don't have any questions. Aside from, are you ready? The test. You said you were going to have a quiz at the end of class. Will it be on Blackboard, or are you gonna go to write it? No, I'm gonna write it. It's gonna be right here. But after we're done. It depends. If you keep me occupied the entire time, you won't get a quiz. So now you want to ask questions, don't you? But yeah, it depends on how much time you have. Could you make up a problem for quadratic functions? Okay. Quadratic functions. So do you want vertex form or the normal one? Normal one. Okay. So what do you want the question to do? Just solve for x? Graph it? There's a function. I'll keep it at 4. So, you want to solve it? Plug in a value. Give me f of 3, for example. Polynomial function. Okay. So, well, quadratic is technically a polynomial. But what did you want to do? Factor it? Okay. I'm assuming you want the higher power in the second. So let's do the third. Although I don't think I'll give you a question like that on the test. Oops. Because that was from chapter 1 mostly. I'm not going to give you a question like this on the exam, but might as well. Okay, here we go. F of x. Ooh. Yeah, I can maybe make up anything, but it's not going to factor well. So I need to think about this a little. Let me look up a problem. That might be easier and faster. Right. 1 sec. Man, my internet is not cooperating. Someone write something? After this, can you give quiz-related questions that you think would be fair? Quiz-related questions? I mean, not really, since I don't know what's going to be on your quiz. I literally make the stuff up on the spot. Besides, that would be like cheating. I'll be basically giving you what the quiz is about. Let's see. Okay, how about this one? X cubed plus x squared. Seems kind of simple, actually. Minus 14x minus 24. Right, so oops, this is your polynomial. Where is it? Oh no, it's right here. No can do, sorry. But I am giving you a tutoring session, so just whatever you think you have trouble with, ask me a question about it. So now back to the polynomial. This is a polynomial to the third degree. So you said you wanted me to factor it. Give you the zeros. So let's factor. Now to factor, you actually have to set it equal to 0. Okay? So let's do that. Now, you have x cubed, x squared, negative 14x, and minus 24. So first thing you need to do is try and factor out what you can. So for example, if I grab the first two values, so the x cubed and x squared, I'm just writing it down here without the f of x, equals 0. Now if I grab the first two right here and take x squared as a common factor, you end up with x squared on the outside, and inside you have what? X plus 1, right? Minus 14x minus 24 equals 0. Now we need to look at the second set and see if there's anything we can take as a common factor from there. All right. So we have 14 and 24. So one common number would be 2. And that'll be it, because 14 is what, 2 times 7? And 24 is 2 times 12. It could be 6 times 4. It could be 8 times 3. Right? So many possibilities, but none of them are factorable. Now the trick is that you want to make sure that whatever you factor out leaves you with the matching pair right here. So you can take the pairs out as a common factor. Right? But sometimes it is possible for you to get a question where factoring it by hand is not possible. It's not like having a quadratic where that you can't factor by hand because the numbers don't add up. So you end up using the quadratic formula instead. Now here's a question I've gotten before. Is there a cubic formula? The answer is yes, but you don't want to learn. Trust me, you don't want to even look at that stuff. It's so long and so complicated. So we're not going to do that. So here's a fun trick. You can actually solve this using synthetic division. I can actually have you solve this one using division instead, right? So now looking at it, squared 14x minus 24 equals 0, right? So any ideas? How do you think I'm gonna solve this using synthetic division? Here's a fun fact. When you're solving polynomials, if it's quadratic, positive 24. Why did you change the sign? And what do you mean by the 24? You're close, but I don't know what you mean by it, so I can't say if you're right or wrong. If you look at it, you have a polynomial to the third degree, and the last number right here, just like the quadratic, the last number is the result of the multiplication of every single number, right? Oh, you want to move it? That won't help you a lot, because to be able to factor a function, this side has to be 0. So if you move the 24 and you can maybe factor out an x, you end up with a quadratic, but you won't be able to solve it after that. Make sense? You'll be stuck. So what you need to do here is try to think in the form of parentheses, because that's what factoring essentially is, right? I want to split it into 3 pairs, and it's to the third power. That's why they're 3. If it was 2, then it would have been 2. It's like, okay, now since this has no coefficient, this one's going to be an x, that one's going to be an x, and this one's going to be an x. Yeah? Now, trick is, I want to know what 3 numbers multiplied together give me 24. This one's actually kind of easy to figure out, because 24 is what? It could be 6 times 4, right? It could be 8 times 3, correct? Which means that the numbers are actually 2, 3, and 4. Why did they come up with those? It's because in the first combination, 6 is 2 times 3, right? In this one, 8 is 4 times 2. So they're the exact same. 3 numbers and all of them. No, this is a fun question to try and figure out, but he asked for it, so this is not gonna be on the test. Don't freak out. Yeah. Yes. So knowing this, like having figured out that the zeros are 2, 3, and 4, right? And that the result of the multiplication is negative, so I already know one of them is going to be negative, and it's most likely the biggest one, or the biggest number of the 3. So here's what I'm going to do. I'm going to write, actually a good thing I have it right here. I'm going to write the coefficient of the polynomial in number form. So like this, for synthetic division, right? That's what it looks like. I have my window right here. Leave room. And then you're going to choose one of these to place in here. Let's go with the 4 first. Now here's the trick. If after dividing the remainder is 0, then it worked. You chose the right one. Okay? If it didn't, change the sign. Yeah? I think this is actually easier than factoring, but it depends on how you look at it. I'm getting inspired right now. Okay. I've never actually taught this trick in class before. So to start, first number goes down directly. You don't touch it. And then you multiply it by the number in here. So 4 times 1 is 4. You get 4. You add 4 plus 1 is 5. 5 times the 4 is 20. Addition gives you a positive 6. 6 times 4 is 24. 24 plus negative 24 is 0. Worked. Means, since I have a 4 here, that means that the x minus c idea, right? That means that my pair of parentheses that I divided the function by is x minus 4. And the quadratic I'm left with is x squared plus 5x plus 6. So my function now, f of x, the one we started with, looks like this. Right? Now it's a quadratic. You can factor this. Plus x. X. 6 is 2 and 3. Add them up. They're both positive. And this one was the negative one. That's the answer. Who had fun? I know I did. That was a good question. But yeah. But don't worry, there won't be a question like this one on the test. I'm only including chapter 2 and paragraphs. Yeah, I've been before that. Sometimes math should be categorized as its own language. But if you know how to do math, you speak one more language than you think you do. They have no idea how right they are. Like, I remember my senior year in college, when I was still in my bachelor's, my math classes didn't look like math. Like, we didn't see numbers as often as you'd think. Like, most people go, "You're a math major. What's this plus that?" It's like, a math major, not a calculator. Do you have any idea when was the last time I saw a number? Oh, all letters. Anywho. Any other questions, you guys? Window to this problem. I'm a little confused. Window in this problem? Is that a reference? I don't know. I don't. Like, I literally grew up in the Middle East, so. Oh, go up. Yeah, sure. This is where I technically start playing with it. Before, it was just nothing, really. How far do you want me to go? You can still see the synthetic division after this. Okay. You were explaining that's what you said. Oh, you're talking about the little window. Okay. Yeah, I do call this a window, but I'm talking about this little number right here. So when you're using synthetic division, the C value, which is the number inside the pair of parentheses you're dividing by, yes, goes inside this little teeny tiny box right here. So you don't write it like the other numbers, so you don't confuse it with it. You just write a little box up there. So it kind of looks like that part of the long division. So I'm just gonna do this so you can get the idea. Okay. So it's the same idea over here, but without the overhead. It's just that part. To separate the number from the rest, that's all. So I call it a window. All right. Yeah. You guys have any other questions? Hieroglyphs. That's what your answer to him. Hieroglyphs. If you want, I could start writing in Arabic, then it will be hieroglyphs. But yeah. Fun fact, did you guys know that numbers are actually Arabic? These numbers. This is an Arabic language right now. See. Oh, cool. Yeah. Funny thing though. Hold on. Jonathan, did you finish copying this? Good. Okay. So, fun fact about this is that actually in the Middle East, up until I was in like in the 8th grade, so somewhere in the 2005-ish year, they were using a different set of numbers, even though these are the Arabic numbers. We didn't use those in math class. We use these in English class, which now I find hilarious. Yeah, so this is not what we used in math class. In math class, the numbers look like this, so I'm writing each one under the one you guys know. This was 0. This was 1. This was 2. This was 3, 4, 5, 6, 7, 8, 9. We use these instead, which are Indian. Not sure why. But yeah. Right? Another fun fact, 0, when it was first invented, it looked like this. But then they split it between the two number systems. So, I'm not sure why it looked like that, but I'm just glad. Okay. Any other questions, you guys? Okay, I'm gonna let you off the hook. I'm not gonna give you a quiz. Make up one. No. If you don't have a question, then that's fine. Plus, you don't want me to make up one, because if I'm trying to make up one, I'm gonna try to make it fun, and it might end up like the last one. So you don't want that to happen. Yeah. All right. So if you have questions, stick around. If not, you're free to go. And good luck on your test on Thursday. Bye.